what I will do is that let me discuss this problem and the rest of the problem guys try, and then if you face any problem, then we discuss. So this was the question that I gave in the last time, right, guys?
Yes, sir.
Let me discuss this problem and then we'll discuss. Only two topics are in. One is the Kirchhoff law and the second one is the Wheatstone bridge. So those two topics are very important in this chapter because every time they will ask me question from those topics. So yeah, okay. So let me first discuss this problem and then we'll talk about Kirchhoff law and Wheatstone bridge. Okay, so yeah. So we had this problem, right? And the hints that I gave is that first identify the repeating, right? So this was the repeating loop that we had. And then I said that put it equals to R. So yeah, I told you guys to put it equal to R and then solve the circuit. So let's say that this is the repeating loop and I put it equal to, let's say this is these are the three circuits that, and the rest ones are right. So let's say that I name it as, so this is 1 ohm, this is 3 ohm, and this is 2. And this is the repeating. So this is the repeating loop, and I just assume that to be this is R, right? So the total this would be again equal to R, right? So let us solve this circuit, and then this is the result that we want. Okay, guys. So we want to calculate the resistance from A to B. So first we will solve this point, right? So at this junction, what would be R effective? So these two are 3 ohm and R are parallel, right? So if two resistance are parallel, then what is the equivalent resistance?
1 by R is equal to 1 by
Yeah,
R1 plus.
yeah. So that is direct result. So if we have only, yeah, you are correct. But if we have only two resistance, so we can write as R1 R2 divided by R1 plus R2. Right. In this way, we can solve this quickly. So this is parallel. These are parallel. So the equivalent resistance would be, this is 1 ohm and this is how much? So this is 3R divided by 3 plus R. Right. So this is what? This is 3R divided by 3 plus R. And this is A and this is. So now we have this one and we have this two, right? And we have calculated, yeah, yes.
Sir, why is it 3R?
Okay, so R1 and R2. So you have R1 which is 3 ohm and R2 which is R, right? Is that clear? Yes, is this clear, Maria? So we have two resistances. R1 is 3 and R2 is R. Understood?
Yes, sir.
Okay, so then we have all these three are in series. So 3r by 3 plus r and 1 plus 2, which is 0. And I assume that equivalent resistance is how much? So this was R, right? This was R, right? Is that clear to you guys? Clear, or do you guys have it out? Because you see that this was repeating, right? So this was repeating, and I assume the repeating one to be R. So if let's say total is R, and then this one is also repeating. So from this point, this is R, right? Then I have assumed that total is R. So this total would be equal to R again, right? Because this is going to infinity, right? So if let's say that total is 10,000, or let's say this is 1 lakh, and then you add some small number to it. So it will be equal to again 10,000, right? 1 lakh. Is this clear? So I calculated the R equivalent and then put it equal to R. So is this clear to you guys? Yes, guys, do you guys have any doubts? You can ask me.
No, sir, no doubt.
Okay, so this is how you solve the infinite series problem. You just put it R equivalent to R, and then you find the repeating ones. So repeating ones, and then you put it to R, and then R equivalent is also R. So this is R equivalent, right? And this is equal to R. Okay, so this was the whole idea. And then this is, so this will become 3R plus 9 plus 3R divided by 3 plus R equal to R. So this would be how much? 6R plus 9, and then this is 3R plus R square. So R square minus of 3R and minus of 9 equal to 0. This is the quadratic equation, and what would be the solution? Yes. What is the solution of this quadratic equation? Alpha and beta would be minus of b plus minus b square minus 4ac by 2a. Okay, so this would be minus of minus b and plus of this is how much? B square, which is 9, minus of 4, and a is 1, and then into 9 minus 9. So by 2. So this would be 3 plus minus, this is 36 plus 9, 45, and then divided by. So the resistance cannot be negative, right? So the answer would be 3 plus 45 by 2. And how much is root 45? So 3 plus, and this is 9 5s are 45, so 3 5 divided by 2. This is the answer. R equivalent is 3 plus 3 root 5 by 2. Is this clear to you guys? Do you guys have any doubt? Yeah. Do you guys have any doubt?
No.
Okay, so let me just again. We had this circuit, and this part was repeating again and again. So what we did was that we assumed that this total is R equivalent is R. But what we saw that this is again, or no, this part is again repeating from here, right? So then what we did was that we put this part again to be up. This was the whole idea. And then we calculated R equivalent and put it equal to R. So this was the whole idea. Okay, you guys please note it down, and then we'll solve the next Kirchhoff law. So then we'll talk about the Kirchhoff law. You guys please note it down. And if you guys have any question, please don't hesitate to ask. Whenever you guys want me to scroll down the screen, you guys please do.
Sir, can you please scroll?
Yeah. So whenever you guys want me to scroll down the screen, you guys do.
Sir, can you please?
And whenever you guys have noted, please check. Okay, noted. Saad has noted. Aisha and Maria, what about you guys? Done. Mariam,
Yes, sir.
one. So now let us come back to what we did. So we were doing a Kirchhoff law, right? Kirchhoff law or rule. So we had, I said that we have, right, one was the junction rule and the other was this or voltage or so let us talk about this junction. Okay. So this junction rule says that let's say that we have this point. Okay. So this is a junction, right? Where all the resistance are connected from where. So this is a junction, and let's say that from here this one current is passing, right? From here, let's say this one current is going out, and then let's say this is I3, and then this is I4, right? So you guys can see that how many currents are there at this junction? Yeah, how many currents are there at this junction?
4.
Yeah, 4. And how many are incoming and how many are outgoing?
2 are
2 are incoming and 2 are outgoing.
Yeah, so 2 are I1 and I4 are incoming, right? And I3 and I2 are outgoing. So this junction rule says that the number of or the total current going or outgoing from a junction would be equal to total current income. Right. So what is the total incoming current?
I1 plus I4.
Right. So I1 plus I. This is the total incoming current. And what is the total outgoing current? Yes,
I3 plus I2.
I2 plus I. Right. So the junction rule says that according to junction, so from junction to I1 plus I4, this would be equal to I2. Okay, so this is the basic junction, right? And why does this arise? So this arises due to the conservation of charges, right? So the total charges coming, right, it will be equal to the total charges out. So that is why the current, total current incoming, this would be equal to total outgoing. So the cause of this or this is the result of conservation of charge. Right. So in the first chapter, you learned that charge had 4 properties. One was the quantization, second was the additive, third was this conservation. So due to conservation of charges, the tension will happen. Okay. So you guys please note it down and then we'll talk about the voltage or right. what Edukiran. Yeah, you guys please note it down, and then we'll talk about it. And then we will see how for complicated circuits we can see that what's the use of this Kirchhoff laws. These are very important and they come very handy when you have a very different or very difficult kind of circuit. So that's where this Kirchhoff law comes in. And this is a very important topic, and this comes. So let me just make it some star. This is a very important one. Okay, noted everyone. Done. Aisha has noted Saad and Maya. What about you guys?
No, sir.
Oh, you are noting it down. Please, note it down. Okay, Saad has also. Mariam noted. Okay, the second rule is right or voltage. So total voltage in a loop would be right. So this says that let's say that you are calculating, you have this point. This has some, let's say this has some voltage V, okay, and this has some resistance. And I have this point A and B. So is this a closed loop? Yeah, is this a closed loop? From A to B, is this a closed loop?
No.
Yeah, so yes, correct. Remove my impact. So this is not a closed, right? So if I want to calculate the voltage across this point, so VA by VB would not be 0, right? So what do I mean by some closed? So let's say that I start from here. So let's say that I start from here, right, and then go here and then come here, and let's say this is some other voltage, and then come here and then. So let's say this is A point, this is B point, this is C point, and this is D point. So if I start from here, right, and I go to B, and then I go to C, then I go to D, and then come back to A. So if I calculate the potential difference, so how much that it would be? The potential difference in a closed loop would be how much? So VA is, right? This would be the potential difference. So this would be VA minus VA, right? So how much this would be? So in a closed loop, right? That is how you calculate all the potential and then come to this point. So in closed loop, the total voltage would be. Is that clear to you guys? Is that clear to you?
Yes, sir.
Yes, sir.
Okay, so Okay, so this is the voltage rule, and this arises due to this arises due to conservation of energy. Right, total energy would be always conserved. So these are the two rules that we follow in Kirchhoff. Right. There is a sign convention which is very important. So I will talk about that. But let us, yes, you guys please note down this part and then I'll talk about the sign convention. So any doubt in these two topics, in these two rules? Do you guys have any doubt?
No, sir.
Yeah, so this is an open circuit and open not circuit but open loop, and this is a closed. Whenever you guys have noted it down, please take. Noted, guys. Yes, guys, noted.
Yes.
So now let us talk about the sign convention. So whenever you have, let's say, this cell, and you are assuming the loop in this direction. Okay, so then the voltage would be minus. Okay, and let's say if you have the cell like this, right? And then your loop is in this direction, right? So first you will see the low potential. So whenever you first see the low potential, then voltage will be positive, right? So let me write it. I will show some example and then it will be clear. Okay. And let's say that this is the resistor and the current is flowing in this way, and this is R, right? And you have assumed the loop in this direction. Okay, so then the voltage would be minus of, whenever you are in the direction, so this would be minus I. And whenever you have this resistance, right, and the current is going in this direction. and then your loop is in this direction. So then the voltage would be positive. Is that are these informations clear?
Thank you for explaining.
Yeah. So let's say that I have this. Okay, I have this circuit, this closed loop, and let's say the current is passing in this. Okay, and this is A, this is B, this is C, this is D. Right. So if I am choosing the loop in A, B, C, D, A, so I am going in this direction. Right. I have taken the loop in this direction. Is that clear? Is this clear? So you see that if I'm going A to B, right? If I'm going A to B, so in this resistance, the current is in this direction, but my loop is in the opposite direction. So what would be the voltage for this point? What would be the voltage? Yes. What would be the voltage? For this point, right? For this point, my loop is in this direction and the current is in the opposite direction. So voltage would be how much? Plus
plus
I,
V.
plus IR, right? Plus IR. Is that clear? Now you see that I am encountering the positive or the high potential first. So the voltage would be negative or positive. Yes, negative, right? And then this current is going and coming in this direction, right? So this current is coming and coming back in this direction. So again, I am going in this direction and the current is coming in this direction. So what would be the voltage at this point?
Positive.
Positive again. So this would be I and R, right? And I don't have any other voltage source, so this would be total voltage. So V would be simply IR plus IR, right, from D loop. Is this clear? So is the sign convention clear now? Yeah. Is this clear now, guys?
Yes.
So please note it down and then I will give a question. You guys quickly try that and then I will do two questions. So those two questions are very important. And one of them always comes in the final exam or yeah, those questions are very important. You guys please quickly note it down. Okay. And if you guys have any doubts, you guys please don't hesitate and ask. So if you guys have any doubt, and whenever you guys have noted it down, please tell.
Done.
Done. So Saad and Aisha, done. Okay, so let me give you guys a question. And you guys just tell me that what are the voltages. So total contribution of voltages. So this question you guys will tell, and I will draw all the. This is a NCERT question, an NCERT question. Okay, so this is the circuit. This is A, this is H, this is B, right? And this is this is D, this is uh, this is F, and this is G. So this is let's say this is positive terminal. So let's say one current is flowing in this, and let's say that it is I2. Okay, so I2 is flowing in this way. So if I2 is flowing in this way, so current I2 will come, right? And let's say that from here,
Yes.
yeah, so let's say that from here I3 current is 1, right? So in here I3 will come, right? And so in here you have I2, and in here you have I3, and in here you have, let's say, I4. Okay, so this is I1. And what are the resistances? So this is 40 ohm, and this is 1 ohm, and this is 45 volt, and this is 80 volt, and 1 ohm, and yeah. So this is now you guys tell me that. So let's say that how many loops do we have? We can have 3 loops, but let us consider only 2 loops. So we have this loop and this loop, right? So let us assume that one loop is this, and this is, so let's say this other loop is here. Is this clear, guys? So
Yeah.
the question is that you have A, and you are going from this direction. So A, H, D, C, B. So you have 2 loops, right? You have 2 loops, and this is A, H. One is A, H, and D, C, B, A. And the other one is what? So you are going from in this direction. So let's say that the other one is, so you are going in this direction. So E, okay, and then D, and then C, and B, and A, and G, F. So these are the 2 loops, and you have these 2 loops, and you guys tell me that what are the, for first, what is the loop rule, and for second, what is the. So you guys quickly calculate and tell. Yeah, did you guys understand the question? Okay, so Saad got disconnected. So we have 2 loops, and we have to write all the contributions of the voltages. So you know sign convention, You know the direction of the currents. So you guys please calculate all those voltages and quickly tell. Then I'll have 10 minutes. So then I will talk about two questions that are important. Are you guys calculating? Oh, so I can ask. We have two loops and you guys are here. So I can ask. Okay. Yeah. So the question is that these are two loops that we have. Okay, Aisha. These are two loops and this is the direction of the loop and this is the direction of the loop. Okay. So we are assuming that overall current is flowing in this direction and overall current is flowing in this direction. So this is the one loop and this is the second. Now, what a loop rule says that, so we have to apply the second law of Kirchhoff. So voltage rule we need to apply. So let's say A. We are starting from A and H. AH is here. So what is the current that is flowing? I1. Right. Loop is in this direction. So let me use the other. So loop is in this direction and current is I1. So what would be the voltage, Aisha? What would be the voltage? Yes, what would be the voltage, Aisha? Minus IR, yeah, minus IR. So first one is correct, right? Minus IR, so I is I1, right? So minus of 30 I1. So Mariam, is that correct?
Yes.
Now let us come to this junction, right? So this is the junction that I have. And a loop is in this direction. Right, so what is the first terminal that I'm seeing? Lower terminal, right? Lower potential. So this is 45 volts. So what would be here, Aisha? What would be here? Yes, Aisha. What would be here? IR. So this is a potential, right? This is a cell. So we know the voltage. Yeah. So we know the voltage, right? 45 voltage. So this is a cell. So we know the voltage, right? So we don't need I and R. We don't know about the resistance. This is a potential device, right? This is a cell. So as you said, plus 45, right? So is this clear? Yeah, is this clear? Okay. Now I shall come to this part because so we have loop in this direction, right? Current is flowing in this direction and current is I3. Resistance is 1 ohm. So what would be here, Aisha? What would be here? Minus IR. So how much is current? Correct, absolutely correct. So how much is current?
I3.
I3 and resistance is 1. So 1 into
1
I3,
ohm.
1 I3. Right. And now let us come to this. So what is the other voltage source? This one. So the loop is in this direction and the current is in this direction. Right. So what would be in here, Aisha? What would be here? Yes. Minus I, yeah. So minus I is I3, right? I3 is flowing. I3 and voltage is resistance is 40. So minus of 40 and I. And total would be how much? So now we don't have any voltage, right? Total would be how much?
0.
So the first equation that we have is 30I1 plus 45 minus, so minus 41I. So this is the first equation that is this clear, guys? Clear? Okay, now Maria, next next loop is full. So we are starting from here. Okay, we are starting from here and the loop is in this direction. Okay, and the current is again in this direction. Current is how much? I2. Okay, current is I2. So you tell me what should be here.
Plus IR.
This is same direction, right? I2 and so plus or minus.
Minus IR.
Yeah, minus I is I2, right? I2 is flowing,
Yes,
right?
sir.
And 20. So minus 20 I2. Clear?
Yes, sir.
Now we are going to D. So D and then again we are seeing this fellow. So what would be here? Voltage we know.
Plus
Yes.
plus.
Right.
Yes, sir.
Now again, so we have come to this part. So this is same, right? So this would be how much? Yes.
Minus IR.
Yeah, absolutely. After loop 2, can you explain plus V and minus V? I understood only minus IR and plus. Okay, okay. So yeah, I will explain it. Good that you guys are asking. So minus of I, what did you say? I3. And then we are coming to this guy. So I3, right? Again, same direction. So minus 40 I3, right? And now we are,
Yes, sir.
and now we are coming in this part. So this guy, right? So what would be in here?
Plus 80.
Plus 80, and then this guy is right. So this is the loop that we are considering, right? This is the loop and
Yes,
the
sir.
current is in this direction, I2. So what would be in here?
Minus
Minus and
IR.
I2, right? So these are the two conditions. Any doubt? Minus 20 I2, minus I2, so minus 21 I2. And minus I3, minus 40 I3, so minus 41 I3. And plus 45 plus, so 125. This is the second equation that we have. So any doubt? Okay, so Aisha is asking about the voltage. So you see, Aisha, whenever we are going in this direction, right? And first we see the high potential. So first, whenever we see the high potential, then voltage would be negative. And whenever we first see the negative potential, lower potential, so potential will be positive. Is that clear to you now, Aisha? So let's say that I have taken this is 40 volts, and I have taken the loop in this direction. Okay, so first I am saying this lower terminal, lower potential. So what would be the voltage? Plus 40 or minus 40?
Plus 40.
Plus 40, right? So this is, so did you understand this part?
Yes.
Okay, so you guys, yeah, where should I put the screen? You guys have noted this part. So please note down this part. And one more thing that I want to tell, that you have used the loop, right? So you used the loop. Now, how many equation you are getting? How
2.
many? Two equation. And how many unknowns do we have? See the circuit and tell me how many unknowns do we have?
2 unknowns.
Two. So
3
again,
unknowns.
three unknowns, right? I1, I2, I3. So to solve three unknowns, how many equations do we need?
2.
We have three unknowns. So can you solve three unknowns from two equations only? Can you solve I1, I2, I3 with these two equations?
3 equations.
Yeah, we need three equations. So to solve this circuit, what can be the other equation that we have not used? So let me give you one. At this junction, what do we know about this junction? Yes,
It is a common
yeah. So it is a
junction.
common junction, and we can apply junction rule, right? Junction
Yes.
rule at A. So what does the junction rule say?
The current incoming is equal to the current outgoing.
So can you tell me about the terms that I have? What is the incoming current? Yeah,
I3.
I and I don't have any other income, right? So this would be equal to outgoing. Understood? So now we have these three equations, right? This one, and now this one. So now we can solve for I1, I2, I3. So you guys can see that if I put the value of I3 in here and in here, so this would be I1, I2 equation, I1, I2. So linear pair of linear equation in two variables. Now you guys can solve that. So please try this at your home, and I will leave this question at this point. So you guys please try to solve these equations for I1, I2, and I3. And please note down this problem. And if you guys have any doubt, so please don't hesitate to ask. Okay. So we have to remember the first idea is that make a loop. Second idea is that draw the direction of the loop, right? And then third one is the remember the sign conventions. So then follow these three steps, and then this is easy. Okay. Yeah. Noted, guys. Please note it down, and then I have half an hour left. Half an hour I have to cover questions and one page to page topic. If this is not completed, then I will take an extra class on Saturday. So we do. Oh, Aisha, you have after applying the job, where does this 125 and 45 come? Huh? Where is in junction rule we don't have 125. So in loop rule we have 125 and 45. So you see this is a voltage, this is a set, right, of 45 volt. So we have to write a voltage. All the voltage contribution would be 0. So we are the loop is in this direction, right? The loop is in this direction, and we are seeing this negative terminal or the lower potential, right? So that is where this 45 is coming from. And in the second loop, we have E, D, B, A, G, F, E. So in the second loop again, we are going in this direction and we are seeing this 45. So plus 45, and then at this junction, we are going in this direction. So we are coming at this terminal, lower terminal. So plus 80. Clear? Yes, this is clear to you, Maya. So that is where this 45 and 80 are coming. And then the total is 125. Is this clear to you?
Yes, sir.
Okay, so please, did you note it down, Maya? Okay.
Yes, sir.
Okay, so now we will quickly do 2 questions and then, yeah, question, very important question. Right. So the question is about the symmetry. Whenever we have some kind of symmetry, then equal amount would be divided. Okay. So let's say that one current is passing and we have 3 resistors, right, in parallel, and they have same resistance. So the current would be equally divided, right? So
Yes, sir.
let's say that 3I current is going from here. So how much current would be here, here, and here?
1 ampere.
Yeah. So and I, right?
Yes, sir.
So this is what we call the symmetry problems. Okay. Whenever we have same kind of thing, so then the division is equal. So we will use this property. So let me draw the question for you. And so let's say this is the voltage supply. Okay. And current is flowing from, let's say, this one and one. And then we have this one. And then we have this one, this one, and then we have okay. And then this is come. So you see that this is a Q. Okay. And all the resistances are, let's say, 1 ohm, 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 and 1 ohm, and 1. Okay. So, right. So let's say that this resistance, this resistance, this resistance are these resistances are equal, right? They are dividing equally. So what should I assume at this junction? So how much amount of current should I assume? How much current should I assume? These are
I.
three, right? 3I. Because three parts, so these are divided in three parts. So then the solution would be simpler, right? If I assume, so if I assume only I, so this would be I by 3, I by 3, I by 3, right? So the calculation would be difficult. Is that clear to you?
Yes, sir.
Yeah, so I have assumed 3I, so this would be I, this would be I, and this would be I. So if 3I is going, so how much it would be coming? This would be 3I, right?
Yes, sir.
So this should be I, this should be I, and this again should be I. Clear?
Yes, sir.
Now you see that at this point, current is dividing in two equal parts. So if this is I, so this would be how much?
I minus 2.
I by 2, half, right? I by 2 and I by 2. Clear?
Yes, sir.
Okay. And at this, so at this junction, right? Again, it is divided in two parts. So this would be how much? I by 2, and this would be I by 2. Clear?
Yes, sir.
Again, this would be how much?
I by 2 and I by 2.
I by 2 and I by 2. So you see, this is I by 2, this is I by 2. So what I will be getting?
I.
I. So you see I is coming. And in here also, you are getting I by 2 and I by 2. So what you will be getting here? Yes,
I.
right? So you are getting I. And in this part also, so you are getting I by 2, you are getting I by 2, so you will get I. Is this clear to you?
Yes, sir.
Okay, so this is a very change. What happened? Yeah. Let me change the color of the current so that you guys can understand. Right. If you guys have any doubt, please don't hesitate to ask. Right. So let me write in different colors. So this is I, this is I, this is I, and then this is I by 2, this is I by 2, and yeah, so we have an assessment after this class. Okay, so we have an assessment. Again, this is I by 2, this is I by 2, this is coming I, and this is I by 2, this is I by 2, and this is coming. Okay, so I by 2 and I by 2. So this is I. And then this is I by 2, this is I by 2. So this is I, and you have this I. And again, this is I, and this is I, and this is I by 2. Okay, so this is I by 2, this is I by 2, so this is I, and we don't have any other currents. Right. And the voltage at this point is, let's say, 2 V. Okay, and now we have to calculate what is the current. So to apply the voltage loop, we should assume some loop, right? So let's see that. Let's assume that, let's say this is A, B, C, or let's say this is A, so this is A prime. This is B, so this is B prime, right? This is C, so this is C prime. This is D, so this is D prime. And let's say this is, okay, so this is E, right? So in A, B, C, C prime, E, and A, in this loop. Okay, you guys tell me that what would be, so we are going from here to here to here to here to here. So you guys tell me that what should be here?
Minus IR.
Minus I. R is 1. Okay. And
1.
at here, what should I get?
Minus IR.
Minus I by 2. I by 2, right? Okay. And in here, what should I get?
Minus IR.
Yes. Minus I. Okay. R is 1. And then what should I? Here, yes, yes.
Plus, plus 2.
Plus 2. This is equal to 0. Clear, guys?
Yes, sir.
So this would be how much? So minus I minus 2I minus I by 2 plus 2 equals to 0. So this would be minus 2I minus I, so minus 5I by 2. And this is minus 2. So minus minus cancels, and 5I equals to 4. So I would be how much? 4 by 5. So this is how you calculate the current of this circuit. Is this clear to you? Is this question clear to you?
Yes, sir.
So please note down this problem, and if you have any doubt, please ask. So, okay, I guess that. Yeah, so on Saturday we'll have an extra class at 5 p.m. So which is 2:30 KST. Okay. Because I can see that I'll have to one more question, and the beats don't reach, so that will take some time. So you guys practice these 3 questions repetitively. The next question, so you guys practice these 3 questions, and these questions are very important. So these will need practice, because yeah, so I also practiced these questions because I was getting some errors. Yeah, you guys also practice these questions, and whenever you find any doubt, please ask. So in the NCRT book, they have taken what's They have taken this to be 10 ohm, right? That doesn't. In the NCRT book, this was not 1 ohm but R. So you can try with that also, right? You can try that and then you get some relation and then you can. Noted, guys. You note it down.
No, sir.
Okay, please. Please. And you guys didn't come in the previous Saturday. There was an extra class and you guys didn't come. Please, this time, please come. Because I need to complete this chapter. And I will start the fourth, yeah, Aisha has put it. And then I'll start. So I guess before your school reopens, you would be completing up to, let's say, 5 chapters. Then we'll be ahead of you. Aisha, in your school, 4th chapter is completed, right? And Mariam, what about your school?
Sir, we're doing the 5th chapter.
Yes, we are on the 5th chapter. Yeah, so let's see, we'll be completing this
Sir?
4th chapter, right? Yes.
Yes, sir. Sir, I have a doubt.
Yeah, sure. So this is, the doubts are always welcome. Yeah, what is the doubt?
Sir, how do we name the junctions A, B, C, D?
Yeah, you can choose any name, right? You can choose any junction. So let's say that you are taking this junction. Okay, let's say that you are taking, not junction, loop. Okay, so let's say that you are taking this loop. We can take also this loop. Okay, so from A to D to C to C prime to E to A. We can take this loop also. Understood? So this is
Yes,
totally
sir.
up to us that, yeah, this is totally up to us that what kind of loop we take. Okay, this is totally up to us. So is your doubt clear? We can write any name, right? We can write P, Q, R, S, T, U, V, W, whatever we want to write. So that is also up to us. Okay, so we can change this name to, let's say this is P. Oh, this is not okay. So let's say this is P. This is Q. This is R. This is S. This is T. This is U. This is V. Whatever we want to name it. So the loop would be what? P, Q, R, U, E, V, and then right. So that is
Yes, sir.
totally up to you. Yeah. So is your doubt clear?
Yes, sir.
Yeah. Okay. So the extension of this question would be that what is the equivalent resistance? Right. So we have this circuit what is the equivalent resistance? So we know that I is how much? 4 by 5, right? And let's say that we can make, uh, let's say this is R equivalent, and the current is how much? This is 3I, and this is how much? 2. So we can calculate the R equivalent, right? So this V would be I, and let's say I prime R, and V is 2 volt, I prime is 3I, and R equivalent we want to calculate. So R equivalent would be simply 2 by 3, and I is how much? 4 by 5. So 2 twos are 4, so 5 by 6. We can also calculate the equivalent resistance. Is this clear?
Yes, sir.
So we can write, yeah, we can write the whole cubical resistor into this R equivalent, and then we can calculate the equivalent resistance. So please note this part also, and all we have only 5 minutes. Okay, anyhow, so you guys please don't miss the Saturday class, because in that class I will be completing this chapter. Okay. Yeah, noted this point.
Yes, sir.
Okay, so the next, Aisha, did you note it down? Yes, noted. Okay, so now let us do the next question. And this is also very, very important. So, very, very important. Okay. So the circuit is, so this is the circuit. So this is again an NCRT problem, and this is very important. This has always been asked. You guys practice this, and this is 5 volt, and this is let's say I3. So if I3 is going, so I3 will be coming, right? And this is I1, right? So if I1 is going, I1 will be coming, right? And let's say this is I2. So we again apply the junction rule here. So this would be I1 minus I2, and this is 4 ohm, this is 1 ohm, this is 2 ohm, right? And this is 4 ohm, and this is how much? So I3 is coming, and yeah. So you guys, let me write the direction of this current in here, and this is. So this is 2 ohm, and this is again. So now we want yeah, this is how much?
Sir,
This is 10. Yes.
sir, why
Yeah.
is it I1 minus I2?
Okay. So yeah, I will ask the question to you guys, that why this is I1 minus I2. So you have asked the question. So you tell me why this is I1 minus I2. Think about it. So let's say this is some junction. Okay. Let's say this is P. And this current is going and this current is coming. Let's say this is X current, right? Let's say this is, so let's make the junction here. This is I2 and let's say this is I1 and X current is going. Okay. So what can you say about the junction? So the junction rule says that I2 plus X would be how much?
I1.
I1. So X would be how much? This is what I have written, right?
Yes, sir.
Clear? Oh, eight. Yeah, so I will keep this question for the extra class, right? And you see I3 is coming. I3 is coming and I2 is coming. So this would be how much? So let us make the junction. Right. So let me have, right. This is I2 and this is I3. Let's say this is X. So X would be how much? Total outgoing, this
I1
would be
plus
equal
I2.
to I2 plus I2, right? So this is I2 plus I2. Okay. And in here, so in here I3 is coming. This is I1. I1 is coming. And in here, so this is I1 minus I2, right? This is I3. Okay. This is I2 plus I3. This is I1. So this would be how much? Let me draw the junction here. This is I1 and this is I2 plus I3. So this would be how much? Yes. So X
I2.
plus X would be how much? I2 plus I3 minus I. Clear? Clear, guys?
Yes, yes, sir.
Okay, so this would be I2 plus I3 minus I2. So what you guys do is that you guys practice this circuit, and we will solve this circuit. So how many loops do we have?
We
How many loops do? Three, right? So we have this one, this second, and this third. So we have three loops, and we will solve these three loops, right? Junction rule we have used. So junction rule we have used at all the junctions. Now we will use the loop. So you guys just practice this circuit because the first part is to make this circuit, right? So you guys practice this circuit at your home and then we'll solve this circuit in the Saturday class. So please be there because I will be completing this circuit. This is very important question and understanding this problem is very, very crucial. And then I will talk about the beats topic. So these were two big questions. So, and they were very important ones. That's why I took time to uh, explain these topics. So if you guys have any doubt in the circuit, you can ask. Otherwise, please log into your Learnivio account. Okay. Any doubt? Do you guys have? Yes.
No, sir.
no.
Okay. So please, yeah, please log into your Learnivio account and don't, yeah, please be there for the Saturday class. So that will be at 5 p.m., which is 2:30 p.m. Because I will be completing the whatever is remaining, right? And then from the next Tuesday and Thursday, I will start the magnetism or magnetic effect of currents. Please, Biot-Savart's law and all the other law I will talk about. Okay, so did you guys? Oh, so first part is noting down. So please note it down and then log into the learning platform. Or take the screenshot of this question. Okay, and because I will be doing the question on Saturday. So you guys please log into the learning platform, right? And see whether the test is active or not. So if it is not active, then I will talk to the learning team.
Yes, sir, it is active.
Oh, it is active.
Yes, sir.
Ah, you noted. Okay. Aisha and Mariam, please log into your Learnivio account and then find the active test. So, Aisha, did you start the test?
Yes, sir.
Okay, so yeah, Rifa has come. So, you guys please join the other room, right? I will talk to them. They will create the room.